Welcome to the DIY Honda Garage channel. The error code C1241-62 refers to an issue with the brake system in the Honda Civic 2022 and newer. Specifically, this code indicates that there is an incorrect correlation between the values reported by the brake booster pressure sensors. The electric vacuum pump control unit monitors these sensors, which are critical for proper brake system functionality. If the discrepancies in values between sensor 1 and sensor 2 exceed a designated threshold, the control unit will register this anomaly and store the DTC, triggering warning indicators or diminished system performance. Accurate sensor readings ensure effective brake operation, making this issue a priority for corrective action. Understanding the underlying functions of each component is essential for effective troubleshooting. The brake booster pressure sensors play an integral role in determining the vacuum needed for the braking system. Brake booster pressure sensor 1 and sensor 2 are located in the brake booster assembly, which is typically found near the master cylinder within the engine compartment. These sensors measure the pressure changes within the brake booster and relay their readings to the electric vacuum pump control unit. The reported values are essential for assessing the vacuum level. If the sensors detect larger discrepancies than specified, the control unit will conclude a fault and set the C1241-62 code. The brake booster vacuum hose connects these sensors and ensures that they are functioning correctly. Identifying the correct location and operational context of these components is key to effective diagnosis. The first probable cause of DTC C1241-62 is faulty brake booster pressure sensors. These sensors may fail due to manufacturing defects, wear, or exposure to extreme temperatures, affecting their ability to provide accurate pressure readings. Another potential cause is a leaking brake booster vacuum hose, which can influence sensor readings by allowing air to enter the system. Consequently, the vacuum levels would not be accurately reported. Electrical issues, such as damaged wiring or poor connections between the sensors and the control unit, may also lead to improper sensor readings. Each of these factors can independently or collectively contribute to triggering the DTC, necessitating careful inspection and testing. Drivers may observe several symptoms associated with DTC C1241-62. Most notably, the brake system warning light may illuminate on the dashboard, signaling a need for immediate attention. In addition to the warning light, the vehicle may exhibit poor braking performance, characterized by reduced stopping power or extended braking distances. A driver may also experience an inconsistent brake feel, finding that the brake pedal feels unusually soft or hard. Depending on the system vacuum. Ultimately, these symptoms not only indicate the potential issues within the brake system, but also emphasize the importance of addressing the DTC quickly to ensure the vehicle's safety and efficiency. The first step in diagnosing DTC C1241-62 is to turn the vehicle's ignition to the on position, ensuring that all electrical systems are active and ready for testing. This allows the Honda Diagnostic System, HDS, to be utilized effectively. When the HDS is accessed, it provides valuable diagnostic information about the vehicle's electric vacuum pump system, including the status of the brake booster pressure sensors. It's crucial to follow the diagnostic protocol outlined in the service manual for the most accurate results. This preliminary assessment is foundational, as it sets the stage for a deeper examination of the components involved in the braking system. Moving forward, the second troubleshooting step involves installing a vacuum/pressure gauge and a suitable hose between the brake booster and the vacuum hose. This setup allows for a precise reading of the brake booster's pressure conditions. Once installed, confirm the HDS readings for the vacuum pressure sensor, signal 1. Normal operating conditions dictate that the values displayed on the HDS should align with those indicated on the vacuum gauge. A discrepancy in these values signals a potential issue, specifically with brake booster pressure sensor 1. Documenting these results is crucial for subsequent steps in the troubleshooting process. For the third troubleshooting step, repeat the process used for sensor 1, focusing on brake booster pressure sensor 2. This requires the same initial setup of the vacuum/pressure gauge and hose to be installed between the brake booster and the associated vacuum hose. After setting this up, confirm the HDS readings for the vacuum pressure sensor signal 2. Just as with sensor 1, the values should match with the readings on the vacuum gauge under normal conditions. If there is a significant difference here, it is indicative of an issue with brake booster pressure sensor 2. This insight helps narrow down the focus for repairs or replacements needed. The fourth troubleshooting step involves a careful inspection of the brake booster vacuum hose, especially if the previous tests indicated normal functioning of both brake booster pressure sensors. Any leaks or damages to this vacuum hose can lead to inaccuracies in pressure readings and, subsequently, to issues within the braking system. To determine if the vacuum hose is the culprit, check for cracks, loose connections, or visible wear. If the other inspection items have shown normal conditions and the hose appears compromised, it likely indicates that the brake booster vacuum hose is the source of the problem, requiring immediate action. Once issues have been identified and repairs have been completed, it is crucial to proceed with final repair verification. First, clear any diagnostic trouble codes, DTCs, from the electric vacuum pump system using the HDS. This action resets the system and allows for re-evaluation without the prior error codes interfering. Following that, retest the entire brake system to confirm its functionality. During this test, monitor the performance of the brake booster pressure sensors and their responses under varying conditions. A successful verification process indicates that the original issue has been resolved, ensuring that the braking system operates correctly and safely. Preventive maintenance plays a vital role in avoiding the recurrence of DTC C1241-62 and ensuring the longevity of the braking system. Regularly scheduled system checks should be performed to assess the condition of brake booster pressure sensors and the vacuum hose. Additionally, monitoring the performance of these sensors during routine diagnostics checks can help catch potential issues before they escalate into faults that affect driving safety. Keeping visual checks on these components for signs of wear, as well as ensuring electrical connections are secure, is also essential. By adopting a proactive maintenance approach, drivers can preserve their vehicle's brake system performance and safety. In summary, DTC C1241-62 highlights issues related to the brake booster pressure sensors in the Honda Civic 2022 and onward. Understanding the correlation between these sensors and performing regular diagnostics are crucial for maintaining brake system integrity. Identifying potential issues early, whether they stem from faulty sensors, leaking hoses, or electrical problems, can prevent serious safety concerns on the road. Prompt repairs following thorough inspections are essential for keeping the vehicle's braking system functioning optimally. By adhering to these guidelines, vehicle owners can enhance their safety and extend the service life of their braking components. Please like and subscribe to the channel. See you next time.